This illustration deals with ambient temperature correction factors in accordance with the NEC 310.15b. The purpose of change here was to provide us a revision. And this revision was made to clarify that under engineering supervision, the ampacity of sizes not shown in the ampacity tables for conductors meeting the general wiring requirements shall be permitted to be determined by interpoling, of the adjacent conductors based on the conductor area. In section 310.15b1 has been relocated from 310.15b2 and revisions made so the authority having jurisdiction will know that an engineer can do this. Now, if we want to kind of look at this in steps, you see the conductors that's in the boxed in circular area here and the conduit. First, we have 3 AWG THHN copper current carrying conductors that will supply the load. And notice that there's 3 of them there. Then you would determine if 3 or 4 of them are current carrying. And the neutral, you can go to 310.14 and look up the neutral conductor there. And I believe it's in C part. And it's only on a Y system that you'd worry about it. But if the majority of the load of a neutral is harmonics, nonlinear load, then that would be considered current carrying. So if you had 16 amps of neutral load and you say half of 16 is 8, and if you're above, usually above that, then they're considering the neutral current carrying. That's what we would look at there. Second, the routed is through an ambient, though, of 125 degrees Fahrenheit. It's talked about in 310.15b as in boy. We have 60/75 degree terminals here. We have 75 degree terminals at the equipment. We have 75 degree ampacity conductors in the raceway to the motor. The motor may be wired with 75 degree ampacities as permitted in 110.14C1 little a4. Now, for the continuous load here, our connected is 32, 125% of 32 amps. That is the calculated load, 40 amp that we would have there. Now, as we have pointed out in 110.14C, then it talks about we can use the 90 degree ampacity of a conductor to derate back to a usable 60 or 75, however our terminals are marked. So 60 degree, as you see by the breaker here, usually for cables. The 75 degree is usually used when you route the conductors in conduit without the cable is identified for 75 degree C, like maybe service entrance cable. Now, let's, you notice in the note it says review the next page and tables 310.15b1 and b2 in the 2020 NEC to get a handle on what's required here. So step 1, let's review that table. 125 degrees Fahrenheit per this table, 76% derate. Now, if you route it through there, more than 10% of the run, you're in trouble. So you reroute it if possible. So now, 2, table 310.15b1, when we do the math, we take the 55 amps from the number 6 or the number 8 that we're using, I believe, there, and we pick up 70% of that, 41.8. So the allowable ampacity is limited to 41.8 amps. So yeah, could you use, say, a number 8? No, because number 8 in the 75 degree column is good for 40 amps. So you'd use a number 6 there to route your conductor. And then you have number 3 AWG THHN. So you're plenty large enough there to serve that. But you could, by this there, you could use number 6 up there if you wanted to. So, but that's just in the illustration. They're showing they've used number 3 because they don't want any problems at all in their routing. And remember, when you tack on that 125% of the connected load, you're derating that breaker 80%. So that's what has taken place here. And I think that explains that about as well as we can without going into further explanation on how you would perform these calculations.